What viral family contains both the virus behind congenital rubella syndrome and mosquito-borne pathogens capable of causing explosive outbreaks of severe joint pain? Welcome to the fascinating world of the Togaviridae family. The family Togaviridae contains a group of medically important RNA viruses that infect humans, mammals, birds, and mosquitoes. Although relatively small compared with some other viral families, Togaviridae includes pathogens that have played major roles in public health, vaccine development, and emerging infectious disease outbreaks. Togaviruses are enveloped viruses with a positive sense single-stranded RNA genome. Their genetic material can function directly as messenger RNA once it enters a host cell, allowing viral protein production to begin rapidly. The viral particle is surrounded by a lipid envelope containing glycoproteins that facilitate attachment and entry into susceptible cells. Historically, the family has been divided into two major genera of medical importance: rubivirus and alphavirus. These groups differ significantly in their transmission patterns, disease manifestations, and epidemiology. The most famous member of the rubivirus genus is Rubella virus. Rubella, sometimes called German measles, is generally a mild viral illness in children and adults. Transmission occurs primarily through respiratory droplets released during coughing, sneezing, or close personal contact. After infection, patients may develop mild fever, lymph node enlargement, and a characteristic rash. In many cases, symptoms are so mild that infection may go unnoticed. However, rubella becomes far more dangerous during pregnancy. If infection occurs during early pregnancy, the virus can cross the placenta and infect the developing fetus. This may result in congenital rubella syndrome, one of the most serious viral birth defect syndromes known. Affected infants may develop hearing loss, cataracts, congenital heart defects, developmental abnormalities, and neurological complications. Before widespread vaccination, congenital rubella caused major public health crises in many countries. The introduction of the measles, mumps, rubella vaccine dramatically reduced rubella incidence and congenital infections worldwide. Today, rubella elimination remains a major goal of global vaccination programs. The second major group within Togaviridae is the alphavirus genus. Unlike rubella virus, alphaviruses are transmitted primarily through mosquito vectors. These viruses circulate naturally between mosquitoes and animal hosts, occasionally infecting humans. One of the most important alphaviruses is chikungunya virus. Chikungunya is transmitted mainly by Aedes aegypti and Aedes albopictus mosquitoes. Following infection, patients often develop sudden high fever, rash, and severe joint pain. The joint pain can be so intense that it may persist for months or even years after the acute infection has resolved. Although mortality is relatively low, the disease can cause substantial disability and economic burden during outbreaks. In recent decades, chikungunya virus has expanded into new geographic regions, demonstrating how globalization, urbanization, and vector distribution can influence viral emergence. Other medically important alphaviruses include Eastern equine encephalitis virus, Western equine encephalitis virus, and Venezuelan equine encephalitis virus. These viruses primarily circulate among birds, mosquitoes, and other animal hosts. Humans are usually incidental hosts. Although infections are relatively uncommon, some of these viruses can cause severe encephalitis, resulting in neurological damage and significant mortality. A defining feature of many alphaviruses is their dependence on arthropod vectors for transmission. This makes environmental conditions, mosquito ecology, climate, and vector control critical factors influencing disease spread. Unlike respiratory viruses, alphavirus outbreaks often follow seasonal patterns associated with mosquito activity. From a molecular perspective, togaviruses replicate in the cytoplasm of infected cells. After entry, the positive sense RNA genome directs the synthesis of viral proteins and new genomic RNA molecules. The assembly of viral particles occurs within the host cell before new virions bud through cellular membranes and acquire their envelope. Today, the Togaviridae family remains highly relevant to global health. Rubella continues to be monitored through vaccination programs, while chikungunya and other alphaviruses remain important emerging infectious diseases in many parts of the world. Together, these viruses demonstrate how a single viral family can exploit very different transmission strategies, from respiratory spread to mosquito-borne transmission, to achieve global success. The Togaviridae family illustrates the remarkable diversity of viral evolution. These viruses continue to shape modern public health and infectious disease research.